Trigonometry, Chapter 7, Applications of Trigonometry Vectors, Section 1, Oblique Triangles and the Law of Sines, Video 11, A New Triangle Area Formula. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we used the law of sines to solve problems and solve triangles. In this video, we revisit the derivation of the law of sines and discover a new area formula for a triangle. When we were deriving the law of sines, we had taken a generic triangle ABC and drawn a segment CD corresponding to the height of the triangle, perpendicular to side AB. Labeling the length of segment CD as H and using right triangle trigonometry on triangle ACD, the triangle on the left, we have sine of A is H over B, opposite over hypotenuse. Thus, the height of this triangle was height equals B times sine of A, obtained by multiplying both sides of this equation by B. Now consider the standard formula for the area of a triangle. We'll use the capital script A for area equals 1/2 base times height. With segment CD as the height, the base would be segment AB, highlighted in orange. Thus, in the formula, the value of the base would be C, the length of AB, and the value of the height would be H, the length of CD. So we substitute C and H into the formula, and we have area equals 1/2 C times H. But recall that H was B times sine of A. We figured that out back here. So we can substitute B times sine of A for H, and now our area is 1/2 C times B times sine of A. Well, we'll put the coefficients of the sine in alphabetical order and put the B first. And thus the area of this triangle is 1/2 BC times sine of angle A. So we have a new formula for the area. Now, this particular formula is a consequence of focusing on angle A. Because remember, way back here, we did the trigonometry on angle A. But since the choice of angle was arbitrary, we could have chosen any angle, we can permute the variables, meaning that we can put them in any order that we want. Thus, we could actually write this formula 3 ways for triangle ABC, depending on the angle that we put inside the trig function. It could be 1/2 AB sine of C, it could be 1/2 AC sine of B, or it could be 1/2 BC sine of A. And notice in all 3 variations, all 3 variables are used exactly once as an angle and twice as a side. Now, if you look more closely at each of these 3 formulas, you'll notice that they have the same structure in terms of the relationship between the 2 sides and the angle. For example, in the first formula with the sides AB and angle C, we see that angle C is the included angle between sides A and B. And in the second one, 1/2 AC sine of B, we see that angle B is the included angle for sides A and C. And similarly for the last one, 1/2 BC sine of A, we see that angle A is the included side, the included angle for B and C. And as a consequence, we can state the new area formula in terms of the relationship between the 2 sides of an angle. The area of a triangle is equal to 1/2 times one of the sides times another side, and maybe I should have subscripted those with 1s and 2s, so we'll do that real quick. All right, there we go. All right, so as a consequence, we can state the new area formula in terms of the relationship between the 2 sides and the angle. The area of the triangle is 1/2 times the product of one side, the product of a second side, and the sine of the included angle. For example, in triangle PQR, we have P is equal to 12 inches, Q is equal to 15 inches, and R is equal to 45 degrees. Find the exact area and the area to the nearest square inch. Now notice that we were given the included angle for the two sides, which is what I just said there. And so the area of our triangle is 1/2 times one side times another times the sine of the angle. So 1/2 times 12 times 15 times sine of 45 degrees. Well, you should know by now that sine of 45 degrees is the square root of 2 over 2. And so if we multiply it all together and reduce it, the 12 would reduce by 2 to become 6, by 2 again to become 3. 3 times 15 is 45. So we would get 45 square root of 2 square inches. And for an approximation, we would use a calculator and get approximately 64 square inches. Now you try. Pause the video and try the following. Find the area of triangle XYZ if y equals 5 meters, z equals 5 meters, and angle x equals 65 degrees. Round your answer to the nearest tenth. All right, if you haven't paused the video and tried the problem yet, here's your fair warning. Solution in 3, 2, and 1. The angle is included between the two sides, so the area is 1/2 times 5 times 7 times sine of 65 degrees, and I only asked for the approximate answer, and it's about 15.9 square meters.